Okay, hi everybody. Um, this is Mr. Walker, your science teacher. We're going to talk about circuits. This is a series circuit. And when we talk about circuits, we're talking about the pathway which electrons can flow and energy can flow along with it in order to power all our devices and homes and everything else that we use electricity for. There's two main circuits. One is a series circuit, and you see it here. It's a circuit in which electrical current has only one path, and you can see that path right here. Okay, it only has that one path. When you throw this switch, then everything is connected. If one of these light bulbs burn out, it opens up that circuit and does not allow electricity to flow. So that's a real serious problem with series circuit. Sometimes you'll see that in Christmas lights. If one of the light bulbs go out, then all the light bulbs go out. So that's one of the negatives in having all those light bulbs tied together. It's one circuit. So when the circuit is open, no electrons can flow through those conductors, which are normally made out of copper or aluminum. Okay. Here is a parallel circuit. Notice that there are multiple ways in which electricity can flow. The parallel circuit is a circuit in which electrical current has multiple paths. Here you have the battery, and it can flow through that circuit, but it also at the same time can flow through that circuit. Okay? Just so long as you have enough power and the wires are large enough to be able to carry all that current, then in terms of amps and electrons, you're good to go. But if one of these light bulbs goes out, it doesn't prevent the energy from, or the electricity from going to the other light bulb. So this is how our businesses and how our homes are wired. They're wired in parallel circuits. How electricity is measured. We use voltage. Voltage is the push. It's the amount of push behind the electron. 12 volts has a push. 24 volts has twice the push. Okay, if you have 12 volts and then you jump up to 120 volts, that's 10 times the push, and you don't need as much current when the voltage goes higher. Some of the circuitry and all the big power lines are in the thousands of voltage. Okay, and the reason, there's a whole bunch of reasons for that, and if you ask me about why is that the case, then I'll talk to you about it. But the volt is used to measure voltage. Volt is used to measure voltage. It is the push. It's how much energy is behind that current. The ampere is the actual electron. Okay, it's how we measure the amount of electrons that are flowing through that system and the amount of energy. Resistance is the opposition to the flow of electric current, and resistance varies depending upon the length, how far you have to push something, and how big a wire you have. The larger the wire, the more energy you can carry, the type of material the wire is made of, and the temperature. And then ohm is used to measure resistance. Okay, here's the power formula. Power formula is watts equals volts times amps. So if you have a 12 volt system and you've got a 24 watt light bulb, okay, you're going to use 2 amps to do that. And so see if you can go ahead and complete those questions, and if you do and you send me some of this answers, I'll give you some extra credit. Okay, and that's the end of the presentation.